In rolling two dice, often we care about their sum and not the values of the individual dice. So we're like rolling two dice and we have it, they're like normal six-sided die. And when we roll them, we want to sum up the faces that are happening there. So if we have a side that's 1, 2, 3, 4, 5, 6, and then we roll a second die. I'm pretty sure you did something like this with Mr. Quelty at some point. I'm sure this is not the first time you've seen this. If you had Mr. Quelty last year, you don't have to remember it. It's fine. But I'm sure Mr. Quelty showed it to you at some point. Okay, so if we showed up a 1 on the first die and a 1 on the second die, adding them together, we get 2, right? If we showed a 2 on the second die and a 1 on the first die, we add them up and we get 3. Same as going down here, we get 3. 1 and 3 would be 4. 1 and 4 would be 5, 6, 7. You get the pattern. Not my first rodeo. So these are the possible sums that you have. These are the possible outcomes that you have when you roll two die. You have 36 possible outcomes, and 8 shows up in a lot of them. 7 shows up in a lot of them. 6 shows up in a lot of them. That all makes sense given what you know about dice game. If you've ever played a dice game before, 7s are ones that show up all the time. So this makes sense. They are 36, a total of 36 different numbers that could occur. And while 6 shows up multiple times, we're still talking about 36 separate events. 5 and then a 2 is different than a 2 and then a 4 and a 2 is different than a 2 and then a 4. And so representing them as all different occurrences is important. We have a total of 36 occurrences. So we're using this for the next page. The next page says find the probability distribution of X using a table and a graph. So finding the probability distribution is this. This is a table of probability distribution, and this is a graph of a probability distribution. So that's what it's referencing, and it sounds really fancy and really smart, but it's all things that you've learned how to do. So when I am making my table is absolutely the thing you want to build first because it organizes, I think it organizes all of your data before you actually have to put it into a graph. So this is the probability that X equals, we start with 2 because our sums start at 2. You can't ever have 1 because you can't have a 0 on a side of a dice. A die? A dice? I'm going to be really mathematical about it. Thank you for bearing with me. X equals 3, X equals 4, X equals 5, X equals 6, 7, 8, 9, 10. Wow, for being mathematical, I definitely didn't do it right. Okay. So those are all of my different possible sums that I can get from this situation, right? So notice that I've been asked a question without ever being asked for a specific number. I'm just asked what's the probability distribution, which means I need to take into consideration the entire sample set or sample size and then break it down into their probabilities. And so the sum of 2, it has a frequency. So I'm going to do my frequency here, and then my probability on the next one. So probability here. Frequency, the number 2 only shows up once. It's when you have 1 and 1 of your die. So that has a frequency of just 1. Whereas 3 has a frequency of 2. 4 has a frequency of 3, 5 has a frequency of 4, 6 has a frequency of 5, 7 has a frequency of 6, and then you'll notice that it starts to go the other way, that then 8 has a frequency of 5, 4, 3, 2, 1. These are all things that we know about dice. I don't think anything is particularly mind-blowing at this point. So then if we wanted to know the probability distribution, we then need to take each of these frequencies and turn it into a relative frequency. In other words, find the probability mass distribution. So 1 divided by 36 ends up being 0.0278, and that's equal to 1 divided by 36, right? Versus the probability of having a sum of 3 is 2 divided by 36, which is 0.0556. Realize that that frequency of 1 is going to have a probability down here of the exact same. That's going to be the exact same, because they both have a frequency of 2, which means dividing it by 36 will be the same. Frequency of 3, in other words, the probability of rolling a 4, is 3 out of 36, which is 0.0833. I'm writing 3 sig figs here, right? Remember that these last 3 digits are the significant figures. Probability of rolling a 5 is 4 out of 36, which is 0.111. Probability of rolling a 6 is 5 out of 36, 0.139. And then 6 out of 36, or a sixth, is 0.1666. Repeating, or in other words, 1.67. Okay, so all I did was take these frequencies and divide them by the total. Your textbook doesn't have you put it into frequencies first. I think it just is easier to make sense to break it down step by step of like, okay, first I find the frequencies, and then from the frequencies, I find the probability from there out of the total possibilities. So that is using a table. To then make it into a graph is that histogram that we saw on the previous page. You don't have a graph for this one, so we're going to go ahead and try the best that we can. This one's going to take a while. So what you need to do is you need to have 11 sections marked off here, starting at 2, then going to 3, 4, 5, all the way up to 12. Remember that each of those sections, the 2 needs to be written, each number is written in the middle. Remember, it's not the tick mark that has the number, it's the number goes in the middle, because that whole bar is representing 2. Then here, our largest probability is 0.167, 16.7%. Which means that you're not really going up very far. You need to go up at least until 17, 18 tick marks, or a distance of that over here. So go ahead, I'm going to cut this out, the next part out of the video. So go ahead and pause the video here until you've finished drawing your scale. Okay, so once you're done drawing your graph, you should have a x-axis that looks something like this, representing the sum of the sides of your dice. There should be a label here on this axis as well as on the y-axis. Write your probabilities either as a fraction or as a decimal. If you want to write it as a percent, you need to write percent here and not probability. And these ones are on the tick marks as opposed to these ones are in between. So the probability of giving a sum of 2 is 0.0278, which is like halfway between 0.2 and 0.4, close to 0.3, right? 0.03. 0.0556 for a sum of 3, which is getting close to 0.6. Sum of 4 is 0.833, so slightly above 0.8.